Welcome to Study Loop.
Hello everyone, here it is given a slender homogeneous rod AB of mass m and length L is made to rotate at constant rate omega 2 about the horizontal z-axis, while frame CD is made to rotate at the constant rate omega 1 about y-axis. Expressed as a function of theta. First part, m1 required to maintain rotation frame. m1 we have to calculate as a function of theta for maintaining rotation frame. B part, the couple M2, this is M1, couple M2 to maintain rotation of the rod. And C part, dynamic reaction at the support C and D. Let us start solving. Drawing its geometrical figure. This is cylinder, centroid, y-axis, x-axis. This is G. Consider this is to be y dash and this is to be x dash. J cap. Omega can be written as angular velocity. Omega is equal to omega 1 j cap plus omega 2 k cap into components along its principal axis g x dash y dash z. Omega x dash will be minus omega 1 cos theta, omega y dash omega 1 sin theta, and omega z will remain omega 2. Moment of inertia along x dash equal to z ml square by 12, and along y dash it is 0. So angular momentum of the slender about g, we can write I x dash omega x dash I cap just a moment. Calculating first in the component form, then we will solve it. So angular momentum about x dash will be I x dash omega x dash 1 by 12 m l square omega 1 cos of theta. H by dash is equal to 0. Hz Iz omega z, that is 1 by 12 ml square omega 2. Calculating along x by z, along the x, y and z axis, Hx can be written as Hx dash sin of theta, that is minus 1 by 12 ml square omega 1 sin theta into cos theta. H by dash minus Hx dash cos theta minus 1 by 12 ml square omega 1 cos square theta, and along z axis you will get 1 by 12 ml square omega 2. So we can write angular momentum about the centroid G minus 1 by 24 ml square omega 1 sin of 2 theta I cap, sin the 2 multiply 2 divide to 2 sin theta cos theta sin of 2 theta 1 by 12 ml square cos square theta j cap plus 1 by 12 ml square omega 2 k cap. Angular velocity of reference frame g x by z omega is equal to omega 1 j cap. So rate of change of angular momentum rate of change of angular momentum h dot g it can be written as, note it down that omega 1 and omega 2 are constant, but Omega 2 is d theta by dt, that is theta dot. So h dot g, you will find hg in the reference frame g x by z plus omega cross hg. So we can write minus 1 by 24 ml square omega 1 omega 2 2 cos of 2 theta theta dot I cap 1 by 12 ml square omega 1 minus 2 cos theta sin of theta theta dot plus omega 1 j cap 1 by 24 ml square omega 1 sin of 2 theta I cap ml square omega 2 k cap. On solving it, this value you will get minus 1 by 12 ml square omega 1 omega 2 cos of 2 theta I cap minus 1 by 12 ml square omega 1 omega 2 sin of 2 theta j cap plus 1 by 24 ml square omega 1 square sin of 2 theta j cap plus 1 by 12 ml square omega 1 omega 2 I cap. So rate of change of angular momentum of the disk about g, you can write 1 by 12 ml square omega 1 omega 2 1 minus cos of 2 theta I cap plus 1 by 12 ml square omega 1 omega 2 sin of 2 theta j cap plus 1 by 24 ml square omega 1 square sin of 2 theta k cap. Say equation number 2. Now we have to draw the free body diagram of the slider. X-axis, Y-axis, just a moment, I am drawing again. z-axis, x-axis, m2, m1. This length is given L. This is centroid G. Here is the reaction D. This is the reaction C. K cap minus K cap. Now, equating moment of the variable couple, L J cap cross C K cap plus M1J plus M2K is equal to H dot G. Substitute the value. If you simplify left hand side, you will get LC I cap M1J cap M2K cap. From equation 2, substitute the value. Here you will get 1 by 12 ml square omega 1 omega 2 1 minus cos of 2 theta I cap 1 by 12 ml square omega 1 omega 2 sin of 2 theta j cap plus 1 by 24 ml square omega 1 square sin of 2 theta k cap. Now equating the coefficients of unit vector, you will get for j cap you may write m1 is equal to minus 1 by 12 ml square omega 1 omega 2 sin of 2 theta, and if you equate coefficient of k cap, m2 is equal to 1 by 24 ml square omega 1 square sin of 2 theta. So we can say m1 is equal to, first answer you may write m1 is equal to minus 1 by 12 ml square omega 1 omega 2 sin of 2 theta j cap. Couple m2 can be written as 1 by 24 ml square omega 1 square sin of 2 theta k cap. Now to calculate the reaction, take coefficient of I cap, you may write LC is equal to 1 by 12 ml square omega 1 omega 2 1 minus cos of 2 theta. So C can be written as 1 by 12 m into L omega 1 omega 2 1 minus cos of 2 theta. So this can be also written as 1 by 6 ml omega 1 omega 2 sin square theta. So reaction at C and D can be written as 1 by 6 m into L omega 1 omega 2 sin square theta k cap, and reaction dynamic reaction at D can be written as minus 1 by 6 ml omega 1 omega 2 sin square theta k cap. That's all for it. Thanks for watching it.